Taking a look at numbers 15 and 16. This first question, number 15, landlines versus cell phones. The graph shows that from 2000 through 2006, Americans unplugged landlines and switched to cell phones. Let's take a look at the graph real quick before, Take a look at the graph before we start to actually use it to help us out. Let's see if it makes sense. This red line, or the decreasing line, is the landlines. And it makes sense that this is decreasing because it says that people are unplugging them. They're not continuing to have them. But notice what's happening with cell phone use. It is increasing. Question A says, use the graph to estimate the point of intersection. According to your estimate, in what year was the number of cell phone and landline customers the same? How many millions of customers were there for each? So if we look at this graph, we're looking for where these two lines intersect, and that's approximately right here. Our estimate is 2004 for the year. And if we trace this back, it's definitely going to be an estimate because I'm not sure exactly where this will be. So if I go back right here, is this approximately halfway between 150 and 200? Maybe 160, 175? Let's say 160. It's an estimate, so anything close to that, 160, 170, 175. A little question mark there. That does say 160. Make that bigger. 160 with a question mark. So our estimate is 2004, 160 as an ordered pair. A sentence would be, in 2004, the number of cell phone customers and the number of landline customers will be equal Now the question I have for you before I finish writing the sentence is, what does 160 mean? If I look at on the y-axis, it says number of customers in millions. So we'll be equal at 160 million people or customers. So this is our approximate answer. B says the function, oh, check it out, it's giving me a function. This is nice. I'm going to highlight these to help them stand out. So the function 4.3x plus y equals 198 models landline customers in millions, x years after 2000. I have a 0 year. And then I have another function. The function y equals 19.8x plus 98 models the number of cell phone customers in millions. Use these models to determine the year, rounded to the nearest year, when the number of cell phone and landline customers was the same. According to the models, how many millions of customers, rounded to the nearest million, were there for each? We're first asked to define our variables. It's kind of nice because if I have a graph, I really can just look at the graph. But if we don't realize that years is here, notice it tells me X years after 2000. So X will be number of years after 2000. And then once I know how many years it's been after 2000, I know the number of customers in millions. Another way of knowing that is it's saying that this function is modeling the number of cell phone customers in millions. So that's what Y represents. That's the total. So cell phone, number, put a number sign, number of customers. And I'm not going to specify landline or cell phone. I'm just going to say generally the number of customers. They both say Y equals. Or excuse me, they both have Y present. Here, Y is customers, but specifically cell phone customers. In the yellow equation right here, Y is customers, but it represents landline. So we'll just say number of customers in millions. Let's pull the equations we were given out. So the two equations are 4.3x plus Y equals 198, and Y equals 19.8x plus 98. The question is, according to the models, two questions. Use these models to determine the year when the customers are the same, and then what is that number of customers? So we need to solve the system to figure that out. Bringing back all of our prior knowledge, we know that when one or more equation is solved for x or y, we are going to use substitution. We have those nice 3 guiding steps we can use to help us out. Solve. Well, that's nice because that's been done for us. One is already solved, 19.8x plus 98, and I'll put that in a box. First sub, we will write the equation we did not use yet, which is 4.3x plus y equals 198, lined on the equal sign. Remember that housekeeping piece to this that we talked about when we learned this in the skills review. Move over a little bit so that you have room to substitute in what you've got. And what do you have? Well, notice this says y equals. So I have something to substitute in for y. So where we see y, we will substitute in 19.8x plus 98. And this is equal to 198. Now we're going to rely on all of our algebra skills to make this happen. 4.3x will stay, plus 19.8x plus 98. I was able to kind of just drop the parentheses. I didn't really have anything to distribute in. E equals 198. Let's combine like terms. 4.3x plus 19.8x. What do you get? Let's do 4.3 plus 19.8. I got 24.1x. The plus 98 is still there. Equals 198. We'll subtract 98 from both sides. So 24.1x equals 198 minus 98 is 100. Last step, divide by 24.1. Divide by 24.1. So 100 divided by 24.1 is 4.15. Well, I got 4.149. Let's put it like that for now. So here's my math answer. but we had some rounding directions. So X is years, correct? Let's see. Yep, X is the years. It says round to the nearest year. So 4.149 becomes 4 years. But not just 4 years. We know it's 4 years after 2000, which would be 2004. Lastly, our second sub, we know X, we need to go find Y. This equation already says Y equals, so let's use it. Y equals 19.8X plus 98. Where we see X, we will substitute in 4. Plus 98. Let's see, 19.8 times 4 is 79.2 plus 98. Plus 98. I got 177.2. There's my math answer, but how do I apply this to the question? This is number of customers in millions, and I have rounding directions again, round to the nearest million. So to the nearest million, 177 million. How well do the models in Part B describe the point of intersection of the graphs that you estimated in Part A? So our original prediction, let's see, was 2004, 160. 2004, 160. The calculated answer, 2004, 177. I would say we were pretty close. Anybody who said this should have been 175 as our estimate on the graph, up here, you would have been even closer than me. Nice job. Let's talk about 16, T-Mobile versus Verizon. Demetrius is in search of a new cell phone plan. He is considering 2 different cell services from 2 different providers. Verizon offers a monthly fee of $99.99 and charges 5 cents per text. T-Mobile offers a monthly fee of $79.99 and charges 8 cents per text. Demetrius is unsure which plan to choose. He wasn't very careful with his last contract and paid a lot of extra money in charges for texts. Write an email to advise Demetrius which plan to choose. We are trying to figure out if one is better than the other. So right away, I know I got a y equals mx plus b system. Let's first define variables, x equals y equals. When we have a y equals mx plus b system, let's work towards finding per each or every. Per text jumps out. Per text. So I know that x is number of texts. And once you know how many texts you're going to send, the number of texts, you'll know the total. Number y, for y equals mx plus b systems, y is always a total. In this case, total cost. What are we comparing? We are trying to give him advice on what? 2 different providers. And what are the providers? We've got Verizon. And we've got T-Mobile. I'm going to make Verizon yellow. Get your highlighters. What do we know about Verizon? Verizon offers a monthly fee of $99.99 and charges 5 cents per text. Translating that into our equation, y equals, this is a one-time fee each month, so just $99.99 flat rate for the month, plus 5 cents per text, so 0.05x. I'm going to make T-Mobile blue. T-Mobile offers a monthly fee of $79.99 and charges 8 cents per text. So that would be the monthly fee, $79.99. Make that neater. Y equals $79.99 plus how much per text? 8 cents, 0.08x. We've got our system. We're ready to set them equal and find first, when does it not matter? Because before we give him advice on which to choose, we have to figure out when they're the same. So this will be $99.99 plus 0.05x equals $79.99 plus 0.08x. We want to gather all of our x terms to the left, numbers to the right. So go ahead and pause if you need some time to wrap this one up before we compare answers. I choose to subtract $99.99 from both sides first. $0.05x is still here. $79.99 minus $99.99 is 20. The plus 0.08x is still here. Next, I will subtract 0.08x from both sides. That's now gone. 0.05x minus 0.08x, negative 0.03x equals 20. We will divide both sides by negative 0.03. I got x equals 666.7. That's my math answer. What does it mean in the real world? Well, no company gives away anything for free. So even though technically this might look like we round up, we will round down to 666 texts. So they're the same at that many texts. Let's say Demetrius really isn't that much of a texter. He likes to call people instead. Let's say he only sends 100. Assume 100 texts. Let's compare. For Verizon, that would mean y equals $99.99 plus 0.05x, but instead of x, let's substitute in our 100. That's $99.99 plus 0.05 times 100 is 5. Adding the $99.99 to that, his bill for the month, sending 100 texts with Verizon, would be $104.99. Let's compare to T-Mobile. Which would be y equals $79.99 plus 0.08 cents per text times 100 texts. That will be $79.99 plus 8 Adding that together, $79.99 plus 8, we get $87.99. What advice are we going to give him? So, dear Demetrius, but I don't have room to write that. Less than 666 texts. Choose T-Mobile. We chose a random number less than the break-even value, and T-Mobile came out cheaper, which means for any number of texts less than this, T-Mobile will be cheaper. On the flip side, if you had chosen something bigger, 700, 1,000, then Verizon would switch to being the better choice. So less than the break-even value, T-Mobile is the way to go. More than this number, Verizon is the way to go. As long as you have the math to back up your recommendation and you conclude it with a sentence for your advice, we're fine. Completely acceptable. Good job. 17 to 24 will be day 6 work. So it'll go 17 to 22 is the next assignment for you to work on for homework. 23 and 24 will round out classwork. Great job, folks. Send any questions on Remind. Have a good day.